than 3 or 4 days ago. They all did better. They all had pink glasses on. They liked what they were doing. I like this pain. It didn't hurt when it hit my toe. Pink makes you happy. Okay? Is there a phrase? Are you in the pink? Huh? Look at today. Feeling a little blue? That's our style. Feeling a little blue? Are you in the pink? There's some truth to some of these things. The canopy support. What do we have for canopy support in the literature and when we anthropologically and otherwise? We know for a fact there was a uniform distribution of energy throughout this globe. From the poles all the way to the equator, we had uniform distribution of energy. The canopy set us up as a greenhouse, perfectly balanced, so that it was just about as warm at the poles as it was at the equator. There was very little, when you look at the fossil records, there is very little climatic zonation moving from the equators up to either pole. They're just the opposite. It's all uniformly distributed. This world was once completely tropical. Okay? Fewer meteorites in the older strata. A gentleman by the name of Fritz Hyde wrote a book called Meteorites in 1964. He's from the University of Chicago. And he noted that in his research, that as he got down to the lower layers of the earth, got through the strata that was considered younger strata, that as you got down lower, suddenly meteorites all stopped. There's no more meteorites. Why? You had a canopy. You had an electromagnetic field that was gargantuanly stronger. And it basically kept the small meteorites from targeting the earth. Burn them up, send them out, they're gone. No meteorites. That's very consistent with the canopy. Residual amounts of water in the stratosphere. Up in the D layer of the ionosphere, 53 miles up, are water cluster molecules. 6 water molecules are all around a positively charged hydrogen. All 6 of these molecules are sitting up there 53 miles up. What is water doing 53 miles up? It would, well, they're coming after us. The water is up there because if you have a rag that's wet or sponge, you can wring it out as hard as you want. I did that when I was a kid. I hurt myself trying to get all the water. I know it can be done. Well, I couldn't do it. It was still wet. Okay? Same thing up there. The water came down, as it says, but the water is still some residual wringing out to do. We have water, and the evolutionist to this day still has no answer to explain why there is water above, except for Scripture. Appearance of a new sun. Very interesting. A new sun. You look at the literature, Sumerian literature, Babylonian literature, the very old literature, and they all talk about a new sun. Sudden appearance of a new sun. It was at that time that they started worshiping the sun, and you had sun worship. Why was there a new sun? Think about it. As soon as 8 people step off the ark, what do they see? A mean sun. It's bright. It's harsh. It's hot. It burns your skin. That sun never existed in the antediluvian world. That sun came out now. Now there's a new sun. And they talk about it. And now these 8 people tell their children and their grandchildren, and it passes on, that there was a sun in the past that wasn't like this. This is a new sun. And they talk about a new sun because there was a canopy that protected them. The antediluvian world, the flora. I'm going to talk about what the world looked like as far as flora. Dr. Keith Morey, we're going to talk about the Lycuspid club moss, cattails. Let's talk about Dr. Keith Morey. Dr. Ikemori is in Keio University in Japan. Dr. Mori liked cherry tomatoes, but his wife relished cherry tomatoes. So, like a good scientist and husband and loving gentleman, he decided to grow a cherry tomato plant. But now they're in Tokyo, and there's no land out there to grow anything on. But he's a smart man because he's at the university. So he goes to his physics lab and he grabs a fiber optic cable. And he sticks the cable up and runs it down the other end down into his basement. And he has all these pots of tomatoes plants all sitting here, you know. And he goes, great. So, after 2 years in his basement, he harvested, well, let's put it this way. After 2 years in his basement, he had tomato plants that were 16 feet tall. Okay, and he harvested 903 baseball-sized cherry tomatoes. His wife said, I don't like cherry tomatoes. So he took it up to the university. And you can find this on the internet. He built this great big huge area to continue his experiment, because he said, you know, the fiber optic cable coming down, the difference between the light coming in and the light outside is what? No ultraviolet radiation. Fiber optic cables filter out ultraviolet radiation. So he had all the sunshine, but no ultraviolet radiation. Look what I've got. I've got next to a near divorce. So he now takes the stalk. He takes the stalk of the tomato plant, not the whole tomato plant, just the stalk, seals it in a tube, and increases the pressure to a couple atmospheres and pumps in a little bit more carbon dioxide. Okay? 14 years later, okay, Dr. Mori had tomato plants, individual plants, that were 40 feet tall. He harvested at the 14th year, he harvested over 15,000 baseball-sized cherry tomatoes. The university at that point in time said, we either buy more space for the campus or you stop it. He stopped. So, look what happens when you have more pressure, more carbon dioxide, void of ultraviolet radiation. You have these gigantic cherry tomatoes. And that's the genes of today's cherry tomatoes that are already destructive and not as good as what it was in the past. Lycuspid club moths. In the fossil record, Lycuspid club moths are, well, today it's 18 feet. It's 120 feet. The Lycuspid club moths, 120 feet tall. Cattails, they're 6 feet tall now. In the fossil record, they were 60 feet tall. Cattails, 60-foot tall cattails. New Siberian Island, a gentleman by the name of Edward Cole was a explorer, and he goes up north of the New Siberian Island outside of Russia, and they find a 90-foot tree. It's a fruit tree, 90 feet tall, with ripe fruit. It's frozen. And there sits a 90-foot tree sitting up in New Siberian Island. Antarctica. In Antarctica, we see fossils of all kinds of tropical plants, leaves from all kinds of plants and trees in Antarctica. And even in Antarctica, they have found coal. Coal is made from substances that were once alive in the plants. What is that doing in Antarctica? Remember, it was a great, big, huge globe with 70% land, 30% seas. And you didn't have that north-south change in climate. You had an even distribution. And if you have an even distribution of energy, you would expect to see these things. The western United States, we have palms, we have broadleaf deciduous plants, we have conifers, all in the western United States. Sitting out there in Texas and New Mexico, that's all kind of deserty. What are they doing there? Because at one time, there was the even distribution of energy due to the canopy. The antediluvian world had very large animals. The bison. West Texas State University has a bison on display. Now, our bison today are about 5 to 6 feet at the shoulder. Okay? These bison that they found in the antediluvian world as fossils, the bison were 10 feet tall.